questions?
Yes, number 43 is a picture.
All right, I don't have a photo from you.
That's okay.
I can send you some photos.
What's that?
I can send you some photos. I have those.
I have a question about, yes, sir, I heard it, obviously.
Okay, so we got that one is explained, that problem shows up again in chapter 7, and it's much easier to explain in chapter 7 than it is here.
Yeah,
But
but if it's on the quiz, and I don't know what's on
Yeah.
the quiz, I kind of.
oh, I
I'll let
have
you show it.
Three. This is quiz.
so we have it's
It's one line, yeah,
that
and then loop, yeah, and then loop down, loop up, straight. Yeah,
all right. So it was part C.
it's, and the question asks,
We have begun.
we have begun, the ball is released at the left.
Wait, hold on just a second.
What is the average?
Sorry, I'm having a hard time hearing. And my hearing's bad enough as it is. Thank you. All right.
It says the ball is released at the left end of the 3 tracks. The tracks have been bent to equal length pieces of the channel island. So A is the fastest to the slowest, rank the speeds of the ball at the right ends of the tracks.
All right, so first off, ranking them at the end, I'm just making the assumption, I can't remember if they stated it explicitly, I didn't hear it just then, but that the drop is the same from here to sort of that next level, that drop is the same across the board.
It
Right.
is the same.
I think it, based upon the way that they are drawn, I believe that was the intent. Now, that is from the starting point to that sort of main level. So when the balls get to here, they'll all be going the same speed. Then they're gonna cruise along, this one's gonna continue at whatever speed that was. This one will cruise along at that speed until it gets to here, then it goes down another hill, so it'll speed up.
Yeah.
This one will cruise along, speed up, slow down back to the original speed. And so in the end, this will be the fastest at the end. Those will be the same.
Okay, and then the second question is from the longest to the shortest, rank the track in terms of times for the ball to reach the end.
I'm trying to remember, they had the same length of track that they've been, all right, so the distance it's gonna travel is the same regardless of the track.
Yeah.
So just imagine, this is sort of, the control right here.
Yeah.
So this one up to here would take the same amount of time.
Mm-hmm.
But then in that last little bit, it's gonna be traveling fast, it travels faster, so this will take less time than this does.
Mm-hmm.
Over here, takes the same amount of time as it gets to here, but then it speeds up, it's traveling at a greater speed for that distance, and then it slows down. So ultimately, this will be faster than that, because there's a segment where it's traveling faster. Between these two, it comes down to the drawing. Is it traveling faster, in which scenario is it traveling faster or longer? Well, based on the way it's drawn, it's traveling along this part faster than, it's traveling along here for a longer time than here,
Okay.
or a greater distance, I should say, probably better wording. So this one should be faster than this one, which is faster than that one. Keep using faster incorrectly. We're doing ranking of time.
Yeah.
This will be the shortest time, next shortest, next shortest.
Okay. Okay, so the answer you put down was A, B, C.
Ranking from greatest to smallest?
Longest to shortest.
Oh, okay,
Times.
Yeah,
Okay, so,
this was the least amount of time,
okay,
so therefore, that was the most amount of time. I did it reverse, apologies.
And then the greatest to least, rank the tracks in terms of average speeds for the ball. Or do all the balls have the same average speed on all three tracks?
Well, what's the formula for average speed?
So it's,
Ashlyn?
Is total distance over time?
Yes.
total-
The total distance is the same for all of them.
Yeah,
So the difference would be the time. And so the least time would have the greatest average speed. And so I guess ABC was for time from greatest to least, and average speed would be CDA.
okay.
Another question, but a different one.
Okay, any other questions on this one? All right, Ashlyn has a question, Lanaya has a question, Ashlyn and Lanaya.
Number 88, the ball on the ramp, when it goes like, it went like straight down and then there was a curve and then it was like this.
Right,
Which, I forget what the question like actually is.
On which of these hills does the ball roll down with the increasing speed and decreasing acceleration along the path?
I was just confused
Yeah, I was
which
confused.
one it would be. I thought it would be C, the one that is accelerating, decelerating.
all right, so we had straight,
Yeah,
curved like that, curved like that,
Yeah.
yeah,
and balls rolling in each of the cases.
Yes.
In this case right here, there's no change to the path. The velocity will increase and the acceleration is gonna be constant, because there's nothing to change it. So this is constant acceleration, increasing speed. Because you're looking for the one where some combination of changing speed and changing acceleration.
roll down with increasing speed and decreasing acceleration.
All right. This one is gonna start out really fast. It's got the steepest of all of the slopes, so that's gonna, imagine the extreme of free fall, it's gonna accelerate the most versus having something to sit on. Because this sort of levels out like this, the speed is gonna change most rapidly here at first, and then the speed is not going to change as much as it comes out the more level. So therefore, since the speed changes more rapidly at the beginning than the end, my acceleration starts out larger and becomes smaller. So I have a decreasing acceleration and an increasing speed. Here, I also have increasing speed, but because it gets closer to, vertical as we go, the acceleration will be increasing.
So but the question, then the answer would be B according to what you just said.
So what? Do them in the same order? Do them in the same order. All right. On which of the hills does the ball roll down with increasing speed and decreasing acceleration along the path? They're all increasing speed. And decreasing acceleration. It would be the, what do I written down? What does the book solution say?
I don't have the answer from the book.
All right, so I'm guessing the solution comes up with a different answer?
I wasn't sure. I thought it was B.
It is B.
I didn't look at the answer in the book.
All right.
I was just confused of which one it would be, but you said it was B, so that makes sense.
Yeah, make a note and hopefully check to see what the book solution is, unless you probably have it right there.
It says only the middle hill, the middle one.
The middle one? Okay. All right. So that matches what I said.
So my question is, for the last hill, the acceleration increases, but doesn't it become constant because the acceleration of gravity? And then would it decrease?
We have to rely upon the picture here
It's like right here.
at the very end. If that is, let's say, part of a circle, then it's only going to have acceleration of, the acceleration of gravity at the very end. So acceleration is still increasing as you go. Now, the rate at which the acceleration changes, in other words, the jerk, might be different. That would take a little bit more thinking. But the acceleration is still increasing until it hits that maximum one. And I think based upon the picture, it's close to vertical at the end, but not quite until you get to the very end. Acceleration is definitely not decreasing. Yeah, there are a couple of times where the information for the solution comes down to the way you would drew the picture, which is not always obvious. Other questions? So, any other questions on that one? But
I had a question with the boat.
and the boat one was, which one gets across, or there are various rankings, right?
So you're ranking the time to reach the opposite shore and the fastest ride.
All right. So, this is one that depends upon the picture that he's drawing. I think all the speeds are the same, right? All the speeds relative to the river are the same?
It doesn't get there.
It
Same
doesn't?
speed, it is,
Same.
same speed relative to the water.
Okay. So, if you're paddling in that direction, is it a canoe? Does it say boat?
He just says boat.
All right, motorboat. All right, so I got a boat going this way and I have the river going this way. The boat is going to get sort of swept downriver in both cases. So if I think about this in terms of I have a certain amount of velocity going to the right and a certain amount fighting against the river, the actual speed of the boat in our nice ideal situation would just be the sum of the river velocity plus the velocity of the boat. So if that is the velocity of him relative to the river, and that is the velocity of the river relative to the bank, then his velocity relative to the bank is just the sum of those. In the second case, I think he's traveling straight across, the river's taking him that way, and so that would be his velocity. And in the third case, he's going downriver. The river is also sweeping him along, so that would be the velocity. So in terms of ranking of speeds, this would be the fastest speed. Next fastest, the slowest.
I got that right, but B and C was what I didn't understand.
B and C were ranking,
Longest to shortest rank the track of terms of times for.
Okay,
sorry,
in terms of
that's
time?
not- no, I didn't understand A, the time it reached the opposite side of the shore.
okay, the time it takes to get to the opposite shore depends upon, well, the river is going parallel to the bank. So what matters is how much of his velocity relative to the river is that way. And that's one where you need to look at the picture. That whichever one extends out the farthest, which would be the middle one extends out the farthest, therefore it would take the least amount of time to get across the bank. The top one, A, looks like it's extended out next most horizontally. And the way I'm basing it is he drew the lines of the river. I didn't draw them continuously, but one of them goes to almost to a line, one of them goes about halfway, and the other one goes a little bit over the previous line.
saying like, because the middle one touches that, like, the furthest line closest to the shore?
Yeah, that's the fastest going that way.
Okay.
It's not the straightest path across. Or it's not the shortest distance across, but it will be the one that gets over there fastest. Does that answer your question?
Yes.
Other questions on this? Other questions? All right.
So in one of your videos, you used the acceleration due to gravity as 10. Can we do that if we state it at the beginning?
Yeah, let's see, what did it write on the top? They didn't specify, oh, yeah, I have where G of Earth is around 10 meters per second squared. I'm fine if you wanna use 9.8 or use 10. The only time where you definitely can't do that is if I explicitly say, or, like, in a lab. Yeah, never use 10 in a lab. And if you're not near Earth. If this is like the typical group, if there's a problem that requires the use of G, half of you will use 10, the other half will use 9.8. All right, let's do it. If you need a calculator, there's a container of calculators up there.